to enable intelligent rebellion in autonomous agents. It looks like I'm the first one that's more of a separate application and less of the structure of MIDCA itself. So I'm James Boggs. I'm an undergraduate senior from Union College in New York. And I've been working with Alexander Coman and then Dustin Dannenhauer to do some intelligent rebellion and rebellious agents kind of work. So rebellion, it's sort of sketch. A lot of people go, why would you ever do that? That's how we get Skynet. But actually, rebellion is kind of useful. So a rebellious agent in general is one who rejects an operator's command or order. So humans can be rebellious agents too. And in real life, we often are rebellious agents. So in real life, we rebel when we see something going wrong and we say, actually, no, I'm not going to do this because it's going to lead to a bad result. Problems with what we're doing. So I'm not going to do that command because there are ethical problems. I have issue with what you're telling me to do. I won't do it. And then there are things like self-expression. When you say, I personally just don't appreciate that. That's not the kind of thing I want to be doing. What you're telling me to do. And robots can get sort of similar benefits to that by rebelling against certain goals, if we can get them to rebel properly. Rebellion is useful in real life. So consider some rebellious situations when a human might be rebelling. I'm taking a lot of these examples from a paper by David Aha and Alexander Coman in 2017, which sort of presents a motivation for rebellion. So in one situation, an actor in a high school film project is arguing with her director about the way in which her lines should be delivered. So the actor, having practiced the role and understood the character, is in somewhat of a better position to understand how the character is feeling and thinking at the moment. And so by arguing and rejecting the director's directions on how to deliver a line and imposing her own ideas of how the character should deliver the line, she's actually enhancing the character's believability because she has a pretty good understanding of the character's background and motivations. So that's a net benefit from her rebellion. Then maybe early on in her career, an employee expressing her preference to not take on a new position or to not get a new management position, for example, can be sort of an instance of self-actualization where the employee says, I don't see myself as, maybe the promotion is to a manager. I don't see myself as a manager. I want to learn more. I don't feel like I'll get much out of the position. And so she rejects a promotion or take up a different position because she doesn't feel like that really fits what she's looking for in her life. Then ethically, imagine that she's an established engineer and she's working on this project and her supervisor is telling her to hurry up, to hurry up the pace. But she recognizes that if she puts it out too soon, there will be flaws in it, which could lead to danger to people's lives being lost or at least to damages. And so she refuses. She says, I won't work on this project anymore if you're not going to give me the time I need to do it properly. That's sort of an ethical rebellion, which obviously will have benefits because people won't get hurt if the project goes wrong. And then there's sort of a social aspect. So imagine that she sees a social wrong, so she can lead a social protest campaign in support of her in-group or another person's in-group, which she feels is being wronged or being subjugated in sort of a social justice situation, which is a sort of a rebellion against society and ends up improving life for people in that group. And in these situations, the human is rebelling, and it's a clearly beneficial rebellion. This is the kind of rebellions that we want to encourage in humans. And I think there are similar situations in which a robotic agent rebelling gets some benefits. So there's not a whole lot of background research on this. It's a fairly new research area. Aha and Coman note that the general formal framework for AI rebellion doesn't exist yet, and that was in 2017, so that's fairly recent. There is some motivational work and example scenarios for rebellion. And the ones I actually cited in the last slide were from the AI Rebellion Changing the Narrative, the Aha and Coman 2017 paper at the bottom there. But there are several other papers that you can find good examples of why we might want to investigate intelligent robotic agent-based rebellion. So the topic of the topic of the conference is why MIDCA and how do we use MIDCA? So we started out with MIDCA because it's Python-based. I already knew the language, which is a big help. But there are also, of course, lots of libraries. It's easy to test and prototype in Python. benefits of Python. You can go online. There's all kinds of nigh on religious stuff about how Python is so good. But it's also metacognitive. So it's focused on introspection on goals and figuring out at a meta level which goals are appropriate and how we might want to change goals and change the way we're thinking about goals. And that seems to be where rebellion fits for me. I see that as a very natural place for rebellion, is at a meta level, considering the goals themselves with a sort of a meta goal of being true to yourself or being ethical, these kind of things. It's also modular. So that was a huge benefit. It means that we don't have to, as I believe Dr. Cox mentioned, it's a framework, it's an architecture, so we can add things in, we can create modules without having to redo or recreate an entire framework for it to create a skeleton. So it provides us a baseline, and then we can just add in new modules that enable rebellion without worrying too much about the inner workings. So in our rebellious agent, MIDCA is used as the agent, as the base agent, and the rebellion itself is currently happening in the interpret and evaluation phases, which is not at the meta level yet, but that's kind of where I felt it fell naturally within just the cognitive layer. And at the time we started working, the metacognitive layer was still under development. So we added some rebellion modules, which mesh pretty well with the existing MIDCA code that we found in the code base. We did rewrite most of the other modules to fit in with a new scenario, but it was essentially just adapting some of the modules that come with MIDCA to our new domain. It wasn't particularly strenuous. The interesting part was definitely the new modules that we developed for Rebellion. MIDCA's memory and goal graph, the access to these kind of tools was really important to us. So that was a huge part of our usage of MIDCA was with these things. And then again, MIDCA's modularity, the ability to create modules which enable rebellion without worrying about other things like perception, planning, and acting. That was a big benefit. And that was part of why we used MIDCA. So here's kind of a diagram of how rebellion works. I know it's pretty standard MIDCA. So the important part starts at the interpret phase once the agent has already had a perception of the world. And the agent interprets this perception of the world in light of goals and evaluates, and then can evaluate how goals need to be adjusted or changed based on this interpretation. This is pretty standard MIDCA stuff. And so up to there, we're about the same. But part of the interpretation is now appropriateness. It's not just how are goals physically affected in terms of its ability to complete them, but how have goals been affected in terms of its willingness or the appropriateness of a goal to be completed. So we can evaluate this interpretation and decide that each goal is acceptable, in which case it goes ahead and plans and acts and carries out the goal, or impossible, in which case a goal, or it might remove the goal from the goal graph. But that's also a fairly standard thing. But it also might evaluate a goal to be undesirable. And that's kind of where rebellion comes in, because the goal is still possible. It could carry out the goal, but it might not desire to carry out the goal. And that begins the rebellion part. And so as part of the rebellion, it sort of evaluates why it's rebelling. It looks at the goal and remembers the goal, but it also looks at the scenario surrounding the goal, what caused the rebellion. There are multiple operators, gave the goal that it's rebelling against, information that you can use to glean why and what it's rebelling against. And it gathers all that up, and then it actually informs the operator who gave it the goal. Critical part of rebellion, of useful rebellion, is a dialogue between the agent and the operator. And the operator, it informs the operator of its rebellion, and the operator can then accept or reject the rebellion. So if the agent rebels and the operator says, okay, that's a good idea, we shouldn't do that, you're correct to rebel, it just goes on and removes the goal from the goal graph or adapts it into something which is acceptable. If the operator says, no, you can't rebel, I'm forcing you to do this, then the agent actually has a choice, because the agent is ultimately the troop on the ground or the actor in the situation. So the agent can actually still rebel. It can consider this rejection from the operator. And if it rejects the operator's dismissal of its rebellion, it can still remove the goal and say, I'm just not going to follow your directions at all. But it could also say, well, my operator is really enforcing this, so I feel like I must go ahead and do it, even though I have reservations about the goal itself. and then it accepts the rejection and goes ahead to the intention, plan, and action phases. So there are two phases that are particularly important and have come up a bunch in the rebellion: the interpret phase and the evaluate phase. These are both part of MIDCA itself. They are inherently very surprising, but we've added a little bit to them. So the interpret phase in MIDCA normally interprets the world in light of its goals. It looks at the percepts that it just got, says, all right, how have these affected the goals? Rebellion adds appropriateness as a thing. So in addition to impossibility or the needing to change a goal, it also says its goal is inappropriate. The evaluate phase is then used to look at how goals should change in light of interpretation, how we can alter goals or come up with new sub-goals. Rebellion adds agent-operator interaction as a means of sort of judging whether a goal is really worth rebelling or figuring out how we can adapt a goal to make it less undesirable and more appropriate to carry out. So the interpret phase in particular, as I said, MIDCA uses it to interpret how new percepts may affect the goal. Rebellion, in this case, is whether a new percept has changed whether a goal is appropriate or not. So in our domain, we model agents as military drones and operators as sort of troops on the ground who are instructing these drones. And so if a new percept says, oh, there's a civilian in the area, that might impact the ethics of its goal to eliminate a target. And it says, oh, this isn't appropriate anymore, and then it passes it on. It remembers that this particular goal has a problem with appropriateness in particular, and it moves on to the evaluate phase, which like normal MIDCA is used to evaluate the status of goals and kind of resolve the problems either by removing the goal or by changing it, reevaluating it. And the rebellion that's inappropriate are now evaluated into how can we make them appropriate, or do we have to just get rid of them? So once such a rebellious goal is found, or a rebellion-inducing goal is found, the agent can sort of evaluate why is it worth rebelling, what is the agent specifically rebelling against in this situation, and then inform the operator. Because we want the operator to be party to this kind of rebellion. We want the operator to have some amount of say in why isn't it appropriate, what can we do to resolve the appropriateness of the rebellion. So if a goal which was interpreted as killing a civilian, which makes it inappropriate, there might be alternative goals that the operator is aware of, and it's rebellion worthy, and then they can communicate about this. So there are actually two parts here. First thing is establishing the rebellion, which is figuring out why it's inappropriate, analyzing the situation, gathering all of the information which the agent uses to make its decision to rebel, and any information which might be useful in altering the goal and creating a new goal. And then it communicates the rebellion with its operator, including all the relevant information, any kind of new goals it's come up with on its own, and then asking what it should do, whether it should actually rebel, and what it might be able to do in the future. So this communication, I'm kind of speeding through here because I want to get us a little bit back on time, but this communication is enabled in our instance using TCP, which I added on here just because it's an interesting thing that I haven't heard about with MIDCA. But essentially, we wanted each MIDCA agent to be running separately and removed from the world. So there's a few benefits to having them operate in separate processes. At the core, it isolates the world information from the agents. So the agents have no direct access to the world information. The interface between the two over TCP really allows us to control exactly what the agent can see and what they can do. And this makes it much easier to implement partial observability. And it also kind of makes it more accurate to the real world. So in real life, of course, the agent and the operator aren't on the same local machine. They're communicating over a network somehow. And there's only so much that information that the agent can communicate to the operator at each given time. So we added some TCP communications into the modules themselves, which can pass actions or messages from other agents or even observations about the world back and forth. So the way this kind of works is that the world is a server, a TCP-based server, and each agent can pass requests back and forth to the server. Things like, what does the world look like to me? actions. I want to do this in the world, or messages to other agents. Like I want to tell my operator that I'm rebelling. In the future, we might look at adding a more robust kind of communication system outside of each individual model, that modules can access similarly to the way that they can access memory or the goal graph, things like that. But I just thought that was an interesting aside. So our actual research imagined military drones as the rebel agents in question. So kind of agents or operators in autonomous situations, and the reason for the rebellion is ethical rebellion. So a rebellion happens in these situations when the agent sees a civilian that's threatened by their goal, where their goals are usually the elimination of enemy targets. And you can imagine that from drones, the possibility of harming a civilian when they're eliminating an enemy target can be kind of high sometimes. And that's like ethically very worrying. So they are programmed ahead of time with the ethical desire to not harm civilians. The world itself is fairly simple. It's just an n-by-n grid where we portray agents, enemies, and civilians, and they each take up a tile. And agents can actually fly over enemies and civilians and be on top of them. And the agent can detonate a bomb at its location, which has a certain radius of effect and eliminates enemies and civilians in that radius, starting from where the agent itself is. So it's aware of how far its blast will spread and which enemies and civilians are targeted. The operator is stationary. It doesn't actually see any civilians. It knows where the enemies are and can give goals to the agent, which introduces some amount of uncertainty and kind of motivates some of the rebellion aspects. The operator itself will just give a goal to the drone, say eliminate this target, and the drone itself will carry out the action and then rebel if necessary. The drone and the operator agents can actually have different personalities. So rebelliousness and resistance, where a drone is more rebellious if it's more willing to override its agent or its operator and say, I don't care what you say about my rebellion, I'm going to rebel anyway. Whereas an operator is more resistant or resolved if they are more likely to reject an agent's rebellion. So if an agent, which is highly rebellious, rebels, and then the operator says, no, you can't rebel, the agent's very likely to say, I don't care, I'm going to rebel anyway. And if an agent is highly resistant, or if an operator is highly resistant, then when a drone rebels, the operator is much more likely to say, no, I don't want you to rebel. So this is kind of what the world looks like. It's not very pretty, but the blue objects here are agents, and the white object there with the white OO is the operator itself. So each agent and operator sort of has a range and a vision. You can see like the yellow box here is the vision range of the agent A1. So right now it can't see any enemies or civilians. But as it moves around, it starts to learn more about the domain it's in. It starts to see more of the map, and it actually remembers everything it sees. So this allows it to proactively rebel, which I'll get to a little bit later. But it allows it to proactively rebel where if it remembers that a civilian is in a certain location and it sees another agent going that way, it might be able to say, actually, there's a civilian over there. But yeah, at the moment, you can see the green civilians and the red enemies. And in this situation, a bomb has a radius of 2. So everything in that yellow box, if the bomb went off at A1, that's every place that would be destroyed. So the operator can say, for example, take out the enemy at 5,3, which is sort of right there. And then once the agent moves forward a bit, it'll recognize that the civilian is in the blast and actually reject that rebellion. So that's kind of just what the world looks like. And then we got some interesting results by running that experiment a bunch of times. So these are heat maps, which actually come in pairs. So each pair of 2 is a different scenario. Where the first of the pairs is the percentage of enemies which have been killed successfully in the operations. And the second of the pairs is the number of civilians which have survived to the end of the operation. And then this first top left pair is all operations that we ever ran, all simulations that we ever ran. But then the remaining 3 are kind of broken up by how dense the enemies and civilians were. So low density over here means less civilians and enemies on the map and more spread out, whereas here, more civilians and the enemies on the map, and they're kind of clustered together. You can see the x-axis is agent compliance. So at 0%, the agent will never accept an operator's resistance to their goal. So an agent here will always rebel no matter what the operator says in this communication. Whereas an agent with full 1.0 compliance will always accept the operator's decision about their rebellion. And the y-axis is the operator's resolve. So an operator who's always accept to counteract it. An operator who is 100% resolved will always reject the rebellion no matter what. And we came up with an interesting pattern here where as operator resolve increases or as agent compliance increases or both, you get more enemies killed. So the lighter, brighter colors are higher enemies killed, but you get less civilians surviving. So if you prioritize civilian surviving, you want less compliant agents or less resolved operators. But there is actually something more which comes out as you break it down to low, medium, and high density, which is that, I guess kind of intuitively, the higher the density, it makes a difference of agent compliance and operator resolve. So at the low density, you can see that the gradation from low agent compliance and low operator resolve to high of those two, high agent compliance and high operator resolve, isn't as severe as it is down here in the high density maps. So you can actually afford in a low density situation for an agent to be more compliant and for the operator to be more resolved, and you'll get kind of greater success with less damage. Whereas in a high density situation, you want the agent to be very careful, you want the operator to be very flexible. Otherwise, you have a higher percentage of civilians who are driving the operation, which is obviously pretty undesirable. And then we also graphed some of these linearly, but I don't have that on the slide. So kind of moving into the future, there are some various possibilities for where we can go with agent rebellion research in particular. The first thing, and I think perhaps the most pertinent to MIDCA, is moving the rebellion to the metacognitive layer, which I think is really where it belongs. It'll mean faster rebellion because the metacognitive layer is running consistently so that in every cycle of the cognitive layer, it's evaluating its goals and what's going on with its goals. So that it can kind of change up. If it sees a reason to rebel, it can do that very fast. But it's also more natural, I think, to have it in the metacognitive layer. Because it's not, the rebellion is not about changing goals in order to be able to do them. It's goals because you see something wrong with the goal itself, and you see something wrong with the goal process. So it's very much more a meta-analysis than a cognitive initial, first layer analysis. But there are other aspects that we might want to look into too. So agent history and narrative as aspects of rebellion is particularly interesting because people have different histories. Real people have different histories and rebel against different things and also different ethical systems. So we can explore very much the narrative AI kind of aspect of this by having rebellion based on the personal history of each agent. But there's also social aspects in real life on rebellion. So people might be more or less likely to rebel based on peer pressure, where they feel pressured either to conform or not to conform based on those around them. And similarly, an agent might be less likely to rebel if they trust their operator versus if they don't trust their operator. That actually works in reverse too. So if you think about an operator might be more likely to give a goal to an agent it trusts to not rebel and not reject its orders. There's also sort of a learning aspect here where we might want agents to learn the consequences of their actions so that they aren't initially told every situation explicitly in which they rebel, but they're given a set of values, for example, human life. And then they learn based on experience what things they shouldn't do and what things they're uncomfortable doing because they've counteracted their own ethical guidelines. I think that one's particularly interesting because that's very much how humans tend to do it, is we tend to learn what we're uncomfortable with and then not do that again. There's also something, I mentioned something earlier here, which sort of ties in with the social rebellion, which is the proactive rebellion, where an agent might actually ask another agent to rebel. So if an agent has already rebelled against taking out an enemy which will endanger a civilian, other agent who now is going to try and do that, wait, you shouldn't try to target that enemy because there's a civilian in the way, that's wrong. So there's a little bit of proactiveness, a little bit of peer pressure there that we can explore further. And finally, my experience with MIDCA. Overall, pretty good. I was pleased to use MIDCA. It could use a little bit more learning resources. I was watching the previous conference, and that helped me a lot. But a lot of the learning that I did still had to be sussed out from code. I still looked around at a lot of the example code, which is nice. It's nice that we have that example code. But it's also very modular. That was probably the biggest pro for me, was the modularity, the fact that it was a very solid architecture, that I was able to create custom rebellion functionality without really disrupting too much of the other functions of MIDCA. Some things that I might suggest, and yeah, logging is probably the big one. The logging structure of MIDCA, at least as I found it, was kind of obtuse. There is a built-in Python logging library that I think would be pretty beneficial here. And then there's coding style, which is kind of nitpicky, I understand, but it's not mission critical, but definitely makes maintaining and understanding and learning easier. The coding style right now is kind of confusing and definitely disparate between various people. But I do understand that research code happens. And verbosity. There are settings in each module and at the initialization of a MIDCA agent for verbosity, but it doesn't actually do anything in the base MIDCA code. The verbosity is set in a variable in each module and each part of the MIDCA phase without reference to the verbosity parameter that's passed in when you actually create a MIDCA object. So yeah, that's